Now previously we have solved exact differential equation. Sometimes the differential equation, it is not in the form of m dx plus n dy equal to 0. For those type of differential equations, we have different differential equations, means that name is linear differential equation. Means the topic is linear differential equations. How should I solve this linear differential equation? What is the general form of the linear differential equation? The first one, the general form of the linear differential equation is dy by dx plus p of x into y equals to q of x. This is called linear differential equation in y. Once again, dy by dx plus p of x into y equal to q of x. This is called a linear differential equation in y. If it is in terms of y, then the general solution of this differential equation starts with y. Means the general solution of this differential equation is y into integrating factor equals to integral q of x into integrating factor dx plus c. Here integrating factor is e power integral p of x dx is an integrating factor. Separately you calculate this integrating factor and substitute in the general solution y into integrating factor. You write that integrating factor answer equals to integral q of x into integrating factor dx plus c. This is nothing but linear differential equation in y. Sometimes linear differential equation we get in terms of x also. The general form of the linear differential equation in x is dx by dy. Previously dy by dx. Now dx by dy plus p of y into x equals to q of y. There observe the once again that differential equation dy by dx, previous differential equation, dy by dx plus p of x into y equal to q of x. Now this is the general form of the linear differential equation in x, dx by dy plus p of y into x equals to q of y. This is linear differential equation in x. Now the general solution of this differential equation is, if it is in terms of x, the general solution starts with x. Means x into integrating factor equals to integral q of y into integrating factor dy plus c. There integrating with respect to x, here I am doing with respect to y. This is once again general solution, x into integrating factor equals to integration q of y into integrating factor dy plus c. Here the integrating factor formula e power integral p of y dy is an integrating factor. Now like this we can solve the linear differential equation in terms of x and y. Now this is the topic of linear differential equation. In this we have one more differential equation is there, same, which is related to linear differential equation. That differential equation is called Bernoulli's linear differential equation. Bernoulli's linear differential equation. Here also the Bernoulli's linear differential equation in terms of y, Bernoulli's linear differential equation in terms of x. Once again, the general form of the Bernoulli's linear differential equation in y is dy by dx plus p of x into y equals to q of x into y power n. The extra term is y power n. Now the recall the linear differential equation, the same up to here same, but the extra term is y power n. This is the difference between the linear differential equation and Bernoulli's linear differential equation. Now the extra term means you have to remove this y power n, this extra term. Then this is Bernoulli's linear differential equation. We don't have any solution for this Bernoulli's linear differential equation. Special method is not available. Then you convert this differential equation into linear differential equation form. After conversion, you can solve that differential equation by general method, linear differential equation method. Means how to convert? Convert linear differential equation, Bernoulli's linear differential equation into linear differential equation by multiplying with y power minus n and solve the differential equation by linear differential equation method. While solving the problem, we can get very clearly. Now, another one, Bernoulli, the general form of the Bernoulli's linear differential equation in x, that is dx by dy plus p of y into x equals to q of y into extra term is x power n. This is Bernoulli's linear differential equation. Convert this Bernoulli's linear differential equation into linear differential equation by multiplying with x power minus n on both sides. Then automatically it becomes in the form of linear differential equation, and solve this linear differential equation by general method. Means we are converting this Bernoulli's linear differential equation into linear differential equation in other variables. This is in terms of y and x, then we are converting into linear differential equation in terms of other variables with respect to the same independent variable. Like this is the Bernoulli's linear differential equation. While solving the problem, we can get very clearly.